Welcome to our new video. Today's question is subarrays with k different integers. So given an integer array nums and an integer k, return the number of good subarrays of nums. A good array is an array where the number of different integer in that array is exactly k. For example, 1 2 3 1 2 has three different integers 1 2 and 3. A subarray is a contiguous part of an array. So let's understand through an example. Let's suppose nums is 1 2 1 2 3 and k is equals to 2. This means how many number of subarrays will be there which are having exactly two different integers in that subarray. See, this subarray is having only two integers, this subarray two distinct integers, this subarray is two different distinct integers. Similarly, this is having three numbers but two distinct, three numbers but two distinct, three numbers with two distinct, four numbers with two distinct. So I hope you understand the example. So let's try to solve this 1 to 1. What is the 1 to 1 2 3? What would be the brute force you can think? Since it is about subarrays, you will try to generate all the subarrays. How you will generate all the subarrays? Like this: 1 1 2 1 2 1 1 2 1 2, and you can keep a map to identify if it is occurring exactly k times or not. Suppose 1 and 2, then 1 occurs 2 times, 2 occurs 2 times. But maps, you can calculate the distinct through map size. If map size is equals to 2, this means it is a valid subarray. So yeah, then you can increase the count. If you can find, you can increase the count by 1. Then break the while loop. If your map has greater than k, you can break the for loop and you can start from here like this. Then you can increase the count again. Suppose this is actually here the count was in the first loop 1 2 3, it becomes 3. Then here 1 2, this is 4 5, then 1, then 6, then 7. That's how it is calculating. So let's code this brute force approach. For brute force approach, you will take a count and count equals to 0. Then you will take a for loop and I equals to 0 to I less than nums dot size, then I plus plus. Then what you will do? Suppose if make a map of int comma int mp for int j equals to I, j less than nums dot size, j plus plus. If and you will put in the map, put this number into the map, nums of j into the map, and you will increase the count. Suppose if map dot size equals to k, then you will just increase the count. If map dot size is less than k, then you will break. Okay. Yes, if it is greater than actually k, then you will break because it is of no use. Traverse again. Now you can actually return the count and you can see how many test cases are running. Obviously it is big of n square and also taking log n, and numbers can be 9, so it is log 9. So n square into log 9 is the time complexity. Let's run this. See, it is giving wrong output. Why? Because let me see, nums of what I have written. This I have written by mistake actually. Map of nums. I think now it is correct. See, time limit exceeded and 42 cases passed. Now what would be the optimal solution of this? So our question was 1 to 1, 2, 3. 1 to 1, 2, 3. Now map will be used. You cannot deny this. Now you can use 2 pointer and a max length. Sorry, count. I use eraser. Okay, let's put 1 in the map. Count as 1. Increase. K is equals to. Let's take 2. Still 2,1, which is increase the count. Actually, count will not increase. Count will increase only if it is equal to 2. So sorry, count will be 1 first here. Okay, this at here the count increased to 1. Now again R moves here and it increased to 2. So this is also subarray, so count increases to 2. Now again R moves, this is also subarray, count increases to 3. But are you seeing you are missing these cases like these? So how you will resolve this? So when you are facing this problem of shrinking and expanding, so you try to use different approach. What is that approach? We have already discussed in the previous videos. 1 2 1 2 3. We will find suppose less than equal to k, whose count of distinct integer is less than equal to k. How to find this? Using a map only. Suppose 1 is 1 at here, count is suppose 1 initially, then at 2, 1 when it is here, count is number of substring which is less than equal to 2 is this plus this, which is nothing but 2. Similarly, when I move to here, so count changes, and this and this counting is 3. When R moves here, count is 4. When R moves here, we have to update the L, because now it is 3. We have to update the L. L moves here, so it becomes to 1. Still problem, L moves again moves. Now it completely moves, so it is now a valid string. When L moves here, it is a valid string, which is 2. So count is 2. And see, the count is the length of the substring, length of the window, which is L minus R minus L plus 1. This is the size of the window, which is adding up. Are you seeing this? So I think this is the solution, but this is telling less than equal to k, but we have to tell equal to k. So what we can do? For equal to k, we can subtract this. If we will subtract this, we can get equal to k. Now let's code the solution. What you have to do for this, just make a while loop and a map, int count, int, and also map, int comma int, also a left and right pointer, a while loop with r less than nums dot size, put in the map nums of r plus plus, while map dot size is greater than k, you have to decrease the nums value, nums of L. Also, if nums of L equals to 0, and we have to erase it from the map so that our size decreases. Otherwise it will show wrong results. Yes. Now what I have to do? L plus plus, and if not, and rest of the time we have to add in the count. What we have to add? L minus r minus L plus 1, number of subarrays we have to add, and we'll do r plus plus simply, and we'll submit this question. There is one mistake. Let me see. Actually, this is one part. This is less than equal to k. This is less than equal to k. That's why 12 answer is coming. So we have to move this function out of this. Let's move this code up and make a function of it, which is calculating the count less than equals to k, and parameters are same. What are the parameters? These are the parameters we will pass. What we will pass in the function, what will you return, and we will return this nums comma k minus f nums comma k minus 1. See, let's submit it. Now only it is submitted. So what is the time complexity of this? You can see big of n here, and this whole will overall will be big of n. Not every time it will calculate big of n. It will be some part and subpart, some part, and overall big of n. So big of 2n, with map you can say big of log 9, because digits are 9 only. Yes, this is the step. So I hope you enjoyed the video. Thank you, and we'll meet in the next video.